Hey everyone! Welcome back to The Growth Mind. Here, we explore amazing facts, science, and psychology that make you smarter every day. So hit that subscribe button and turn on the bell icon. Because today, we're diving into something really interesting. Do we really boil water faster by adding salt? Let's find out the truth behind this popular old belief. Fire droplet. Introduction. An old wives' tale is a commonly practiced superstition, or belief, that is often regarded as unscientific or incorrect. Old wives' tales have been influencing society for centuries and can be anything from scaring someone when they have the hiccups to drinking whiskey and lemon tea to cure a cold. These superstition-based facts have had a major influence on family traditions and even society as they continue to be passed on from generation to generation. One of the most practical old wives' tales that has become a daily routine for many people is adding a pinch of salt to a pot water to help it boil faster. This simple technique has become common practice for both professional chefs and home cooks alike. Properties of salt water. Adding salt to water does two things. It increases the boiling point and decreases the specific heat capacity. Specific heat capacity refers to the amount of heat that is required to raise the temperature of a substance by 1 degree Celsius. A liquid's boiling point is the temperature at which the substance will start to change state from a liquid to a gas. The heat capacity of salt water is substantially lower than that of fresh water. This means that salt water isn't as resistant to a change in temperature than fresh water, so less heat is required to increase the temperature of salt water. This thermal property could work in the chef's favor and decrease the amount of time required for the water to start to boil. However, the boiling point of salt water is higher than that of fresh water measured at 102 degrees Celsius compared to 100 degrees Celsius. These two properties conflict and will work against each other unless the salt concentration is high enough to counteract the higher boiling point of salt water. Salt water requires a higher temperature before transitioning from a liquid to a gas than fresh water, due to the phenomenon known as boiling point elevation. The addition of any non-volatile solute, such as salt, baking soda, or sugar, to a liquid will cause a decrease in that liquid's vapor pressure. A liquid will start to boil when its vapor pressure is equal to the atmospheric pressure, so a lower vapor pressure means you need a higher temperature to boil the water. This phenomenon also explains why water boils at a lower temperature at the top of a mountain than it does at sea level. On the top of a mountain there is less atmospheric pressure, so it will take less time for the vapor pressure to match that value. When salt is added to a pot of water, it also makes it more difficult for water molecules to escape from the pot and enter the gas phase as vapor or steam. This is another contributor to the higher boiling point of salt water compared to that of fresh water. The lower heat capacity of salt water is triggered by the bonding of salt ions to water molecules. These salt ions hold the water molecules in place, making it more difficult for them to move freely. As a result, the non-salt bonded molecules receive more of the energy provided by the heat transfer occurring through the stove and will get hotter and boil faster. Cooking with salt water. In terms of cooking, most individuals normally add about a teaspoon 3g of salt per liter of water. Adding this small amount of salt will technically make the water boil faster, however, it would only result in a difference no more than a few seconds. In order to trigger a substantial difference in boiling time, the pot would have to contain over a 20% salt concentration. For example, pot A has 100 g of water, and pot B has 80 g of water and 20 g of salt. Pot A, just water, will have a higher heat capacity and will require more energy to boil. The salt in pot B would have dissolved and now has a lower heat capacity than pot A. The pot containing a 20% salt concentration will heat up over 25 times faster and win the race to reach its boiling point. However, this would cause the water to be extremely salty and make the food inedible. So now you know, adding salt might not make your water boil much faster, but it definitely makes your food taste better. Grinning face with smiling eyes. If you enjoyed learning something new today, don't forget to like, share, and subscribe to The Growth Mind, where curiosity meets knowledge every single day. Seedling. See you in the next video. Keep growing, keep learning. Rocket!